All right, so derivatives of inverse trig functions. The first example we're going to do, and in every case here we're going to differentiate. So we're going to find the derivative. So if I have the inverse sine of e to the x as my function, we want to take the derivative with respect to x of that function. Okay. So we simply look at the basic formula for the derivative of inverse sine, and I should have them in front of me, but I do not. You do, so you're going to tell me what to do. What do I do for inverse sine? It's 1 over what, Seamus?
Square root of 1 minus x squared.
Right, and for our sake, x squared is actually e to the x. So it's 1 minus the square of the argument. So the square of e to the x is e to the 2x, okay? And because the argument is a function in x, we also need to multiply by the derivative of e to the x. And what is the derivative of e to the x? E to the x. So we will have as our derivative e to the x over the square root of 1 minus e to the 2x. Okay? So we're just applying the formula with also the chain rule. Okay? We can't forget the chain rule when the inside function is a function in x that we have to mess with. Questions about that one? Liam, does it make sense? Can you see it from there? Okay. All right, how about this one? Cosecant, inverse cosecant of x squared. So that's what my y is, and we want to take the derivative of that. So we look at the formula for the derivative of arc cosecant, or inverse cosecant, or cosecant to the minus 1. What's the derivative here, Sandrine? Look on your textbook for inverse cosecant. Cosecant to the minus 1. The derivative is? Okay? Now for us, however, our x in every case is going to be x squared. So if I have an x squared here, do I need the absolute value?
Is it not negative?
Oh, do we miss the negative? That's okay. Okay, so if I have x squared as x, then this will become x squared, and I don't actually need the absolute value because x squared is clearly positive already. And then this down here is going to become what? X to the power of 4, because I have to square whatever the argument was, and the argument was already x squared, so when I square that I get x to the power of 4. Okay? Now that's not done. What's the last thing I have to do? I have to multiply by 2x. Okay? So when I multiply by 2x, now I'm going to have negative 2x over x squared, x to the power of 4 minus 1. And now one of the x's here cancels, so I have negative 2 over x square root of x to the power of 4 minus 1. Okay? So this is the derivative, but this is the simplified form of the derivative, and that's what we want to do. Yes, Shay?
When you cancel the x, you don't have to put the absolute values back on, do you?
I don't, yeah. And do you know why I don't have to worry about it? Because this was an absolute value. So I didn't care about this one being absolute value or not, which means that it could be positive or negative, and so then I can still have positive or negative here now. Okay? Okay, good question. Other questions, Emily?
So it says x to the 4 under the square root.
Yeah.
Why wouldn't you simplify that?
Okay, how does that simplify?
Well, like, wouldn't you be able to take, oh, I guess because there's still the 1, you wouldn't be able to go x to the 4 over 2 and then x to the 2? Like, can you...
Oh, yeah, no. So x to the power of 4 minus 1 to the power of a half, there's not an exponent law that tells you that you can bring in the half. What you can do is factor that. That factors to be x squared minus 1, x squared plus 1. And then that whole thing's to the power of a half. But that's not a perfect square.
Yeah.
So, yeah. If it was just x to the power of 4, you could take the square root of it. But it's x to the power of 4 minus 1. So that doesn't reduce any further. Okay, but those are the kind of questions you want to be asking yourself is, can I simplify this any further? And if you can, how? Okay, how about the inverse tan of ln x? So we want the derivative of tan to the minus 1 ln x. So we look at the formula and we say, okay, the outside function is inverse tan. So I need to know what's the derivative of inverse tan. What is it, Pun?
1 over 1 plus x squared.
Okay, now for us, the x is ln x. So it's going to be 1 over ln x squared. Okay. And then we need to multiply by the derivative of ln x. Does anyone remember what the derivative of ln x is? 1 over x. So we will have 1 over x, 1 plus ln x squared. Okay? So, right, it's not that hard. We're just using those formulas, which are new to us, but applying them and then using our chain rule, multiplying by the derivative of the inside function. All right, I'm going to do 2 more here. How about this one? Sine of arctan x. So I want dy by dx. So if this is y, what's dy by dx? Okay? So first thing you think, oh, arctan, what does arctan mean? It means inverse tan, tan to the minus 1. So it's exactly what we were dealing with before. But we look at the outside function. The outside function is sine. What's the derivative of sine? Cosine, right. So we're just going to write cosine of arctan x first. And now we're going to multiply by the derivative of arctan x. And the derivative of arctan x is 1 over 1 plus x squared. So we will have cosine of arctan x all over 1 plus x squared. Okay? All right, last one that I will do with you, and then you can do some on your own. This one's a little bit trickier, only in that it's just a little bit messier. Arctan x over 1 plus x squared squared. So we want the derivative of that. What are we going to have to apply here? Quotient rule. We've got a quotient. So we've got arctan x divided by 1 plus x squared squared. Quotient rule says take the derivative of the top first. Derivative of arctan x is 1 over 1 plus x squared. And then we're going to leave the bottom the same. The bottom is 1 plus x squared squared. Now we're going to subtract. We leave the top the same, so that's arctan x. And we multiply by the derivative of the bottom. What's the derivative of the bottom, Dima?
The derivative of the bottom is 2 brackets 1 plus x squared bracket. And the derivative of the inside which is 2x.
Beautiful. Okay? So we have that, and I can make that a little bit prettier, so we're going to try to do that. So I will have, oh, I forgot, I missed something. What did I miss? Last step? Yeah, we have to do the bottom to squared, so I want to square that, so that's going to be power 4. So I almost forgot the denominator. That would be bad news. All right, so we'll make it pretty here I have 1 over x squared, and here I'm multiplying by 1, or sorry, here I have 1 over 1 plus x squared. I'm multiplying by 1 plus x squared squared, so that just gives me 1 plus x squared there. I'm going to bring this 2x over here, so I'll have minus 4x, and I'll do the 1 plus x squared here, and then it's arctan x, all over 1 plus x squared to the power 4. Anything else you can see that I could do here? Or anybody get lost from where I was there? Piper, you got it figured out?
Yeah.
Anybody else have a question about how I got that? Okay, so notice that here I have a 1 plus x squared, and here I have a 1 plus x squared, and down here I have some 1 plus x squares. So it'd be handy to factor these out, because I don't need all of them. So if I factor one of them out, of the top and the bottom, then they're going to cancel with one of these, but I'm going to end up with a 1 minus 4x arctan x all over 1 plus x squared, and now that's going to be cubed. I'm pretty sure that's as simple as I can make it there. Okay? So how that happened, if you want me to not skip this step here, I factored out the 1 plus x squared. So when I factored it out of here, that left me with a 1. And when I factored it out of here, that left me with 4x arctan x. All over 1 plus x squared to the power 4. And then I divided one of those 1 plus x squareds out here and here, and left me with that. Okay? Questions about that? Okay, so your job today is to try some of the questions, or all of the questions from the textbook in dealing with inverse trig functions. And you could start thinking about what you want your formula sheet to look like for Friday. Okay? And I will come around and help you with those. And if you get them all done and you're looking for something to do, you could take your silent reading time that I ripped away from you today. Before we move on to whatever we're moving on to, how are we feeling about the silent reading? Is anybody reading a book that they're really enjoying? Okay?
There are ones that are good, but they're not ones that I choose to read.
Yeah, I understand that. That's why we're having the silent reading, because I'm making you read something that you wouldn't normally choose to read in the hopes that you might learn something. And I understand that you probably wouldn't want to take it out from me and take it home and read it, although I have had students do that in the past. But I'm not offended if that's not what you want to do. But that's one of the reasons why we're doing it in class, is to provide that opportunity to read something that you probably wouldn't otherwise read. Anybody else want to comment on that? Shay, which book are you enjoying that you're reading?
I've switched books almost every time.
Mm-hmm.
But I think the one that I enjoyed the most so far was Struck by Lightning.
Yeah, that's pretty interesting, isn't it? All probabilities and stuff. Yeah, yeah. There's definitely some more interesting books than others there. And then a book you might find interesting, someone else might not, because it's not something they're interested in. But if you have a book that you have read that you think is quite good and you want to recommend it, that's fine. Or if there's a library book that you want to bring in, that's fine too. We will do these again. We'll start reading again perhaps after the term exam. Okay? So we'll put it off for a couple of weeks and then bring it back in. Yeah, all right, I want to talk to you guys about learning objectives and how we're doing that too, but let's not do that today. Let's save that for a little bit later. So do some practice and I guess I could have stopped recording this like a long time ago.